When you solve the system by graphing, you just got to find where they intersect, right? So y equals to x minus 1. You should already know how to graph it. You start from the y-intercept, -1. What's the slope? 1, which is 1 over 1. That's rise over run. So you go up 1 over, up 1, 1 over, rise over run. So you get a straight line, linear function, going through -1 with slope of 1. What about the second equation? It's a quadratic equation. What does this -3 do? Shift down 3. So instead of 0, it goes down 3, and then it's 1 over up 1, 2 over what? 4 up. Oh, so that's where it intersects. 1 over 1 up, both sides, left and right. 2, 4. So it's a parabola, right? So where do they intersect? At this point and at that point. So we get our solution as, you have to write it in an order pair form, right? -1, comma, -2, and +2, comma, 1 is your solution. That's how you solve it graphically. Now, how do you solve it algebraically? Y equals to that and y equals to that. Since they are already solved for y, can we just set those to equal to each other? You're looking for when they have a same y, right? So it is x minus 1, your y, equals to the other equation, x squared minus 3. So it seems like it will become a quadratic equation. So in order to solve the quadratic equation, what do you set the equation equal to? 0. Keep the leading term, the highest power, positive. So I'm going to move x and move -1 by adding 1. So then I get 0 equals to x squared minus x. -3 plus 1 is -2. Now you factor. What two number multiplies to -2 and adds to -1? It is x, but -2 and x plus 1, right? So when does x minus 2 become 0? When x is 2. When does x plus 1 become 0? Because we want to make this whole thing multiplied to 0. So either this 0 or that 0. So it's -1. So is that my final answer? No, you have to find the y's too. So it's 2 comma x. Plug it into one of the equations. What's 2 minus 1? 1, which we had here. -1. Plug it in. What's -1 minus 1? -2, which we had earlier by graphing.